All right, pre-calc friends, now that we've got some general notes on the parabola, let's see what this looks like in action, all righty? So my first example is x squared equals negative 4y. And so I first want to think about, will this open up, down, left, or right, okay? So what I'm going to look at first is this x squared. And because the x is squared, that tells me the parabola is going to be vertical. So it's either going to open up or down. And since there's a negative in front of the 4, it's a negative 4, this is going to open down. Okay? And I see there's no h or k, so the vertex is going to be 0, 0. And now let's solve for our a value. What is the distance from the foci to the vertex, okay? So what I do is I set that coefficient negative 4, and I set that equal to 4a. And I'm just going to solve and get a equals negative 1. But I always just give my a as a positive value. Because we're going to have a distance to the foci, distance to the directrix, it's equidistant. So I always drop the negative and just write it as a positive, right? Because I'm going to have my foci down 1, but then I'm also going to have my directrix, and that's going to be 1 unit behind the vertex, okay? So here's my directrix. Notice it's 1 unit behind, and then the foci is 1 unit in front of the vertex. So because it's like 1 unit this way, 1 unit that way, I just always write it as a positive. But that gives me a focus of 0, negative 1. And then that directrix, this horizontal line, would be y equals 1. And now I'm going to solve for my lattice rectum. Okay, so that's going to be 2 times 1, which gives me 2. So I go to the foci, and I'm going to go out 2 units to the right and 2 units to the left. And then I'm going to connect my the vertex to those endpoints. So that gives me lattice rectum endpoints of 2, 1, 2, negative 1, and negative 2, negative 1. Okay, so lots of symmetry here. Cool beans. All righty, let's try another, okay? So this time I notice that my y is squared. So that tells me it's either going to be left or right. Because of that negative out front again, I know that this is going to open left. The vertex, so to get the x coordinate of the vertex, I look over here. And to get the y coordinate, I look over here. So I get a vertex of 2, negative 1. It's going to open to the left. So now let's solve again for our a. So I'm just going to do 4a equals negative 4. Again, I get an a to be negative 1, but I just list it as a positive. My foci is always going to be in the direction of how my parabola opens. So my parabola opens to the left. So that means I'm going to go 1 unit to the left. And then that means my directrix will be 1 unit behind. So here's my directrix. Now, think of a directrix is not technically part of your parabola itself. It's part of how the locus of points is created, okay? So, you know, the foci and the directrix, I always do them in green because they're not actually part of the parabola. They're part of how it's made. So I like to do them in another color. All right, so my focus here is 1, negative 1. My directrix is the vertical line, x equals 3. And now let's get my lattice rectum. So that's going to be 2 times a, so 2 times 1, which is 2. So I'm going to go to the foci and go up 2, down 2, and then connect my points. Okay, so my lattice rectum endpoints are going to be 1, 1, and 1, negative 3. Right? Cool beans. So this is a parabola. So you can even just seeing the foci and the directrix and thinking, we're saying, this distance is the same as this distance. So like even just seeing that the directrix and the foci graphed with the parabola, I think really adds to your understanding of this U-shaped graph that you've been learning about since you were maybe like 13. So it's kind of cool. All right. Let's move on to example 2. So this part, I'm going to give you some partial information about the parabola, and you fill in the rest, okay? So my vertex is 0, 0. My focus is 0, -3. So right away, that tells me that my parabola is going to open down because the foci is in the direction down from my vertex. And my A is going to be 3, since it's 3 units away from the vertex. All right, so now let's do my directrix. So the directrix is going to be 3 units then behind my vertex. I'm just going to put some endpoints here. So this is the horizontal line. So that would be y equals 3 for my directrix equation. And now let's get my lattice rectum points, okay? So that's 2 times A. So 2 times 3 is 6. So this is going to be a bigger one. Cool. So I go to my foci. 1, 2, 3, 1, 2, 3. Okay. Cool beans. So then fill in the shape here. Alrighty, so my lattice rectum endpoints are at -6, -3, and then +6, -3. Alrighty. So now it wants us to build the equation of this parabola. So if it helps you to jot down the general form or scroll back to that page in your notes, here it is. So my vertex is 0, 0. So this can just be x squared over here. It opens down, so I need a negative. My A is 3. And then there's no K value. K is 0. So cleaning this up a little bit, I would get this. X squared equals -12y. Ooh, I just had a crazy itch. I've got some allergies. Anyone else have some allergies? All right. So the cool thing is, I haven't mentioned this yet, but obviously you guys know you can always plot any of these guys right into your Desmos. Is even, I think, easier than your graphing calculators because you don't have to solve it for y, and you can just plot this right in there and make sure that the parabola it graphs matches up with what we see. So yep, a parabola vertex at 0, 0 that is opening down, and you can even kind of try to see, right, what was the lattice rectum points we had was what, 6, -3, right? And so that would be right around there. So I know that my parabola is correct. So definitely use Desmos here. Alrighty, so there's my final equation for that parabola. And now I've got one more here for you folks before you can start the practice. The vertex of this guy is 4, -2. And then the vertex is 6, -2. So 6, -2. So right away, right, the direction that the focus is from the vertex tells you which way the parabola will open. So this is going to open to the right because the foci is to the right from the vertex. My A value is 2. So that means the directrix will be 2 units behind. And this is going to be a vertical line here. And so this vertical line would be x equals 2 for the equation of that. And now let's get our lattice rectum points. So that would be 2 times 2, which is 4. So go to your foci and go up 4 and down 4. And then here is our parabola. Oh, That was just going to bother me. Okay. Oh, gosh. You know what? I did my best. Hopefully yours looks more symmetric than mine does. All right, let's get our equation here. So this opens to the right, and so that means my y is going to be squared. So I'm just writing the general form of the equation. You don't have to necessarily do that. So grabbing that -2, that would give me y plus, not k, y plus 2 squared equals, it opens to the right, so I need it to be a +4 times a is 2, and then it would be x minus 4. So cleaning this up a little bit, I get y plus 2 squared equals 4 times 2 is 8 for that coefficient out front, and then x minus 4 would be the equation of my parabola opening to the right there. And we could plop that into decimals and check our work here. So let's clear this guy out. Parenthesis. Go away. I don't really know how to get rid of this thing. Anyone know? Go away. So I get y plus 2 parenthesis squared equals 8, and then x minus 4. All right, so we should get a parabola opening to the right, vertex 4, -2. We can check out what were our lattice rectum endpoints. I didn't write them down. So that would be 6, 2, right, is up here, and then 6, -6. So we can just make sure that those are on my parabola. So 6, 2, be like right around here, yep. And then 6, -6 would be like down here. So it looks like this parabola is matches the one that we created, and we are good to go. So those are the basics of the parabola, folks. Make sure you get to the last practice problem. It is a pretty awesome, truly an application problem that Mr. Gibbon risked his life to create for you. So make sure you check that one out. And as always, let me know if you have any questions here. All right, see you later, guys.